Yes, sir.
Wait for a while.
Yes, Lord.
Okay, today's class will be the last class for this semester, and we will make a conclusion at first, and then give you the details about the final report. So at first, we'll make conclusion. Conclusion for the nonlinear, for the second order nonlinear at the first. For the nonlinear circuit part,
Yes, sir.
we have discussed the nonlinear resist circuit. And then we have discussed the nonlinear first order circuit. For the nonlinear first order circuit, we should pay attention to the dynamic load, linear second order. And we discuss from the x equal to ax minus plus b u. We call this state function. We begin from this function, state function, and in this state function, the u always come from the source, the external source or the stimulation, and we assume is zero input response, zero input. So this will equal to zero, So the x equal to ax is a zero input response. The x is a vector. It contains x1, x2. This x means first order differential equal to ax. The A is 2 multiple 2 matrix x1, x2. There's no differential. And we discuss this system at the first. For this system, the balance point will be simple. Balance point means the x1, x2 will not change with time anymore. So the differential to time t will be zero. Equal to zero. So the balance point x1, x2 is 0, 0. So we discuss balance point at first because it's very simple. So we don't pay much attention to it. But for the nonlinear second order circuit, the balance point will be difficult, and maybe there will be several balance points. So at the first balance point, then we discuss the engine value of the second order system. For the engine value, number 1, number 2, it comes from lambda multiple 1001 minus a equal to 0, So it will be lambda minus a11 minus a12 minus a21 lambda minus a22 equal to 0. So from this function, we can show the number 1 and number 2. We go to number 1 and number 2. So case 1, if number 1 and number 2 are all less than so case 1 is number 1 not equal to number 2 and a real part, and 1.1 if number 1 less than 0, number 2 less than 0, then in the case 1, the solution x will equal to k1 e number 1 t eta 1 plus k2 e number 2t eta 2. This is a total solution. And for the case 1.1, number 1 less than 0, number 2 less than 0, and we assume the absolute value number 1 less than the absolute value of number 2. So in this case, we should know how to draw the phase figure. This x1, this x2. And we assume this eta 1. Assume this eta 2. Because number 1 absolute value is the number 2. So when the system to 0, it will tangent to the number 1. And when the system to the minus infinite, it will parallel to the number eta 2. So it will be like this. The figure will be like this. And the point 0, 0 is a balance point. This means from this point or this point, it will move to this, move like this trace to 0, this trace to 0, So it corresponding to the overdamped second order system, overdamped. The case 1.2, if the number 1 larger than 0 and number 2 larger than 0, and assume number 1 larger than number 2, then the figure will be this eta 1 and this eta 2, this eta 2, because number 1 larger than number 2. So when the figure, when the system to the infinite, to the positive infinite, it will parallel to the eta 1. When the system to negative infinite, it will be tangent to the eta 2. So it will be like this figure, but to infinite. It'll be like this. Case 1.3. Number 1 larger than 0 and number 2 less than 0. For this case, we call it these two cases we call unbalanced. This stable node. This unstable node. And for this case, we call it saddle. The saddle is unstable. In this case, the figure will be like if this eta 1, this eta 2, when the time to the positive infinite, it will tangent to the eta 1. When time to negative infinite, it will tangent to eta 2. So it will be like this. This direction. So So this figure show any initial point move in the phase figure. So case 2, lambda 1 equal to lambda 2 equal to lambda, and 2.1 lambda larger than less than 0, 2.2 lambda larger than 0, and in this case the x equal to k1 plus k2 t eta 1 plus k2 eta 2 e lambda t. This is a solution. So in the case 1, it will be assume this eta 1 and assume this eta 2. When the lambda less than 0, when the time t to infinite, positive infinite, it will move from the positive part of the eta 1 to 0, like this, to 0, and this part to 0. So this is phase figure. This phase figure for the lambda less than 0. If the lambda larger than 0, the figure if this eta 1, if this eta 2, it will be like the direction to infinite, to positive infinite. So this for this case, this figure for this case, and this figure for this case, this figure for this case, this figure for this case. And for the case 3, if the lambda 1 and the lambda 2 are complex conjugate, 3.1, assume the lambda 1 equal to 0 plus j omega, lambda 2 equal to, lambda 1 equal to a plus j and minus j omega. So case 1 is alpha equal to 0. In this case, the x solution will equal to k1 cosine, e alpha 1t cosine omega t plus theta, and plus multiple eta r and minus k2 e alpha t sin omega t plus theta eta I. This is a solution. And if the 3.1 this x1, x2, between this eta r and eta I, assume this eta I, and assume this eta r, if the alpha is 0, it will be an eclipse. That means periodic in this figure, periodic. And the direction, this will be periodic. We call this case as center. The center means the balance point is the center. And the case 3.2. Case 3.2. the r less than 0. If the r less than 0, it will move in this figure will be like from this point will to 0 to 0. And point 3.3, if r larger than 0, so in this figure, it will move increase and to infinite. So these three subcases for the number 1 equal to number 2 conjugate. So we have finished the for this case we call it as stable. This case is unstable. This stable focus. This unstable focus. So the focus also means balance point, or the center means balance point. So we have finished discussing the linear circuit. When we discuss the nonlinear circuit, we linearization at first. Linearization the circuit at first. How to linearization at first? Found the balance point. Step 1. Calculate the balance point. And step 2. At every balance point, we can get the matrix A. For example, if the system is x1 equal to f1, x1, x2, the x2 difference equal to f2, x1, x2. This is nonlinear circuit. The step 2 is we will change this nonlinear circuit x1, x2 to A, x1, x2. So this is linearization. How to get the matrix A? The matrix A cut from F1 and F2. The matrix A will be F1, x1 difference, F1, x2 difference, F2, x1 difference, F2, x2 difference, and put the balance point, x1, x2 inside. So we got the linearization circuit. This x1, x2, we can treat it as a small signal delta x1, delta x2. Then step 3, use the linear method. Use the linear circuit method. To analyze. But pay attention for step 3. When you use the linear circuit method, the only case is if the r equal to 0, we can't use this method. So for any other method, any other case, we can use. So this case will also this is not also, and this okay. Only this case, we can't use the linearization. We cannot use it. So this is the nonlinear circuit. We analyze linear circuit at first, then use the same method to analyze nonlinear circuit. And we have discussed wait for a while. We have discussed this example, this nonlinear circuit, and we have draw find the final balance point at first, and then draw the figure, the phasor figure. This is a phasor figure we draw, and this is a real figure. We can find they are very similar. So we can use the linear method to draw the nonlinear secant phasor figure. Okay. Okay, now we make the conclusion for the total course. The whole course. In the chapter 1, we have discussed some basic component and some basic concept, and review the knowledge of the undergraduate course. We have discussed why we call this sector the network analysis. The second, and the system. This three word difference. We have discussed, and then we review the basic knowledge of undergraduate course. In the chapter 2, we have discussed the matrix method. To analyze sector. And the matrix method widely used in the computer simulation. So actually, this chapter how describe the method how computer analyze, how computer simulate a real circuit. So this chapter content. For chapter 3, we have discussed the two-port network. And this chapter comes from the undergraduate course. It will be easy for you. Come from undergraduate course. And chapter 4, we have discussed the multi-port network. For the multi-port network, we have discussed the YZTH parameter. And then we have discussed the multi-terminal network. Multi-terminal network. When we discuss the multi-terminal network, the multi-terminal means for the network, terminal 1, terminal 2, and 3, 4, 5, 6. 1 and 2 can't form a port. So means this current I1 flow in and I2 flow in. They are not equal. And equals. So they are not a port. So it's common multi-terminal network. For multi-terminal network, we have introduced the star to net transform at first. Star to net transform. One star to net transform is Y to data generalization. And then we discuss indefinite admittance matrix. And we also introduce what is the definite admittance matrix. By the indefinite admittance matrix, we can change any kind of circuit connection. We use it to float or connect to ground, and we should connect terminal or float terminal. Should connect also means contraction. The float terminal, this float means we don't use this terminal anymore. Not means use float this terminal to the ground. And we also introduce a parallel of the circuit use IAM. And we also introduce how to use the IAM to calculate the YIC. So the indefinite admittance matrix is widely used in the network analysis. When we discuss the multi-port network, we have also introduced active multi-port network, and we introduced the generalized of the Thevenin's law. Thevenin's law and Norton's law. The Thevenin's law and Norton's law only suitable for the one-port network. We generalize it to the multi-port network. This is chapter 4. For the chapter 5. For chapter 5, we have discussed some basic concept for circuit and for the network. We discuss the number circuit and distribute at first. Then we discuss the time invariant and time invariant. And time invariant. Time invariant. And then the linear, nonlinear. And linear, nonlinear, and the active, passive, and the energetic, non-energetic. We have discussed this concept, basic concept for the circuit. So there's a reciprocal and a non-reciprocal. We have discussed total 6 kinds of concepts for the circuit. And then we introduce the basic components. This basic concept. Basic components. Resist, capacitor, and the inductor, and the memory. It come from the U, I, the Q. Q means charge. The posi means the magnetic chain. If the UI relation we define is resistor. If UQ relation we define the capacitor. Posi I relation we define as inductor, and the Q and the posi relation we define as a memory. Q and I relation, this is the definition of the current. Posi and the U relation, this is Faraday's law, because U is d phi dt, and I is dq. dt equal dt. So these two relation will not form components. All other relation will form components. So we have total 4 kinds of basic components. So the voltage source, current source is not basic component. For the voltage source, we can treat as the nonlinear resistor or nonlinear capacitor. For the current source, we can treat as nonlinear resistor and nonlinear inductor. Pay attention to this problem. The USS is not basic components. And we have also introduced high order components. The high order components is not basic. We can treat it as a generalization of the capacitor and inductor. For example, the D components. The D component we define is the I equal to D mod dO dt, high order difference. The E components, we define U equal to E mod di dt, high order difference. So the D components we can treat as a generalization of the capacitor C components. The E components we can treat it as a generalization of the inductor L components. So the high order components. So this is the total content of the chapter 5. For the chapter 6, nonlinear circuit we have introduced just now. Now we introduce the final report. Pay attention, everybody. For this course, we will not have no final examination because of its online it's online course. We have only final report. Everybody should submit the report in 2 weeks. And for the report, it has 2 parts: part 1 and part 2. For the part 1, everybody should describe your own understanding of every chapter. We have total 6 chapters. You should describe your understanding of every chapter, because it's your own understanding. So everybody should have some difference in the description. And then describe your suggestion for the content of every chapter or for this course. So for the part one, every student should be different. Pay attention, don't try to copy any others. For the part 2, you can choose only one topic from these 6. Everybody choose one topic is enough. Describe the details and the progress of this topic. More details will be better. I have give you 6 topics: the special resist, high performance capacitor, high performance inductor, memorist, nonlinear circuit, and the chaos, and the multiple terminal circuit. And you can also choose other topic. To describe, but your topic must be in the electrical engineering. Okay, do you understand? Hello, everybody?
Yes, Laushi.
Okay.
Yes, Laushi.
Okay, so we have finished all the course. Everybody submit the report in 2 weeks, and I will give you score according to your report. Every one report will include 2 parts. Part 1, for everybody, the part 1 will be different. For the part 2, everybody choose one topic to describe.
Laushi.
Okay.
Have suggestion.
What's your meaning?
Can you please increase the time period, because we have other courses, we have to make a lot of reports so that you can make it clear and more convenient. It can be better.
Can you speak loudly?
We
cannot
would
hear.
like 2 weeks is too small time. You can please,
You
like-
mean 2 weeks is not enough?
yeah,
Okay, then 3 weeks. Okay.
yeah, maybe 3 to 4, and you can give us like a format, how
Sorry?
big the report should be.
Format? No
Yes,
format.
of
No format. No format.
oh, okay.
No format.
Thank you.
Okay.
Thank you.
Any other question?
Yes, Laoshi.
Sir,
Please,
how
many
long-
page?
What?
How many page?
How many page?
Yes, like maximum page or minimum page.
I have no limitation for the page, no limitation. But for your understanding of every chapter, I think you should describe in details. And for the part 2, actually every part, every topic, there much knowledge in every topic. So you should summarize the details, and summarize the progress. Do you understand?
Okay.
So this report is for a course. This report is for a course, for total course. So it will be, I think it should be contain maybe 10 pages, maybe 10 pages. 8 to
All right,
10
Laoshi.
at least. 8 to 10 pages at least. And for the part 1, I think it should contain 2 to 3 pages, 2 to 4 pages. And for the part 2, you should summarize the topic. And you should not just copy. For the part 1, everybody should be different. So if I found any 2 of you or more of you copy each other, I will give you the 0 score. Understand?
Okay, Laoshi.
So don't try
Thank you.
to copy others. Don't give your report to any others to copy.
Yes, Laoshi.
Okay.
Okay, Laoshi.
Thank you.
So if no more question, I will close the meeting.
I think thank you for your time.
Okay, Laoshi, thank you.
You're welcome. See you.
Laoshi, submit our report on your email.
My email? Okay. Yeah. Okay. Wait for a while. My email. I will send my email in the WeChat group.
Okay, Laoshi, okay.
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 Okay, thank you.
Okay. See you.
Thank you.
Okay, thank you, Laoshi.
Thank you.